start car or and then start work automatically.
Now this is on this one. It's a program actually. Maybe after 1 hour it may change to this one also. If you don't know that it's a program. So now the pump is running. During heat dissipation, we are doing heat dissipation. That time you can't touch it. That much work. Up to 95 degree, 100 meter. Okay, so the pump is running. Which pump is running? Also it will show it.
Both of pump nice.
Maybe both are running. Running, no? Both are running. That's right. So both pump is running. It will show you both pump are running. Okay. This circulation pump we call for the heating time. It's like a heating time. It will be circulation pump. Now that also running. Both pump are running. Okay. So it's like a circulator. Okay. So this is only pushing. That is circulator. This both pump are pushing. So the why the both pump are running, maybe it's needed consuming is going very high. You see the rejection is 95%. So it's because RO is running there, that considering is thinking that the water is utilizing, more utilizing. That's all. Okay. So what is
current threshold?
permit temperature is there. Permit means membrane. Membrane temperature is there. Now the inside the membrane temperature will be 16.3 degrees Celsius. Because we are giving already inlet temperature also very less only. What is our inlet temperature? Inlet temperature is 20 now. Right now it's 20. Okay.
Can this threshold, permit threshold?
Permit pressure 4.4 bar.
So which is threshold?
This pressure here only. We have pressure sensors over here. This is one pressure sensor. This is the P2. We have to see the P1. What is the P1? So every step we have like this pressure sensor, conductivity sensor, temperature sensor, complete in the RO system. There are many places. So like you see the T1 here. So T2 here. T means temperature. T1, T2. And T3 and T4. Four sensors are there from beginning to end. Okay, there are 4 sensors in that one. So it will tell you the different stages. This is a heater. T2. This is a heater. This is a temperature sensor. It's somewhere near to the heater. Okay. So like this is also another one near to the heater. And this is the return temperature. It is already going to the patient. The end of the patient temperature. Okay, loop temperature. So like a conductivity, inlet conductivity 135 now it's showing here. Okay, then this is T1 conductivity, then T2 6.9 output temperature of the membrane 6.9. This is input, this is output. Okay, conductivity. Yeah, conductivity of the after the membrane. Then again after the membrane everything passed, it's going next step. You can see 5 conductivity. There are 3 different conductivity sensors over there, so 3 places. And also pressure P1. This is our P1. This is a P1. After the pump immediately, pressure 1, P1. Then it will go to the pressure 2, P2. After the membrane, it will be too much reducing the pressure after the membrane. Then P3. Again second pump, after second pump, P3. Then the P4. Then return pressure, membrane return pressure. I mean the return loop pressure.
Okay. So this the input going to the area. Dialysis room.
Dialysis room. Yes.
And this one is the
Return.
from dialysis room.
That is considering here like this one. This is the input. Okay. This is the output. This is the return. Okay. This return means it's going to the back to the membrane. This is the output. RO output.
Going
Okay.
to the
This RO
patient
in and
area.
out is connected to the our second unit there. Okay. We are not direct connecting the patient this one now. There is another unit.
Okay.
So that's why it's like here we have 2 units. So two different things are going on here.
So the input of the next unit.
You'll go there. You'll go there.
Output of the
Yeah, you'll go there. I will show you that one. So you just see that one. You just imagine in your mind. This is only 1 RO. Don't go for the second RO. So this is a 1 RO. So this is the in. This is the out. Which is going to the patient area and return down. So this is how 1 RO. If you have 1 RO, 2 RO, whatever it is, this is the function of that one. How it works. Okay. Even if you connect the 2 RO also, this will do the same thing only. Okay. So in this one you can see that how the RO is running right now. This is how the RO is running. The part of the water will go to the drain. Excess like high concentration water will go to the drain, and low concentration water will go to the casing. Okay. That's how we come to know that membrane will try to remove the particles, encrustings, and also try to remove the water quality and try to make a good quality of the water in that one. Okay, when it pass through the membrane. So that's it. You can see the parameters, everything like you see now. This is the main parameter of the directive. Directive running time. So here we have a off on button and exit button. If you go exit, you can just while running RO only, you can go for other steps like here. Now we see the RO. This is the RO parameter. We see the 3 stage parameters. Also we have nothing to do with right now here. So also same, we have a HT parameter, heat distribution parameter. This is also right now linked together.
So it's working now.
It's a link together. Okay. So whatever things are going on there, it's trying to indicate over here. Okay. So we can see the temperature, thermic conductivity, and other things. When during the heat distribution, maybe we can see more parameters over there. What's going on here? Okay.
And I talk to you again. This registry.
We program like the timers. You can program the data set timing. Okay, morning 5 o'clock, it has to start data set. We can make a program. But right now we don't make a program. Like the rinsing also we have here, same like RO, that RO you see, there is a program already. If you stand by, automatically it will show you how frequently it will do the rinsing. Every hour, like 15 minutes, it will do this rinsing. Same like heat distribution. You make a program, it will indicate over here. There is a one program already. So this is every week we have a program over there. So weekly it will do the heat distribution itself. We have to come and monitor, but it will start itself. It will initiate itself the program. Okay, automatically. And it will try to increase the heat as per the program. And it's trying to circulate. And then once the regulation complete, it will come to cool down. The cool down complete, it will come to the normal process. Okay.
So all of these parameters can do programming automatically.
Everything is programmed already automatically. We can change if you want. You want to just change the date or we want to change the time. Everything we can done that one.
Okay, one more question. If during the RO is working condition, at that time it will be rinsing.
During RO running,
Whatever program we set, it will be turned on or can be
RO running time, there will be no rinsing.
no rinsing, no heat disinfection.
No rinsing, not rinsing possible, not disinfection possible. It's program itself is blocking. It's a made program. If RO is running, the rinsing program will not take over. It will be automatically shut off.
Only that one in standby.
Standby only it will do that one.
If suppose
Even if you are standby, only you can run the heat disinfection. If RO is running, heat disinfection system it will not allow you to do. Your RO is running, it will not allow you to do. Okay. So that's why if the program is there, suppose if anybody by mistake try to press the heat disinfection, it will not let you to allow.
Yeah, because that one is the safety.
It's safety. They made a safety feature for that one, so it will not allow you to do that one. So here the parameters can be edited. Okay. If I press here, I can put the program for automatic start dialysis. This time has to start, this time has to stop.
So meaning start dialysis, meaning that's the RO system.
RO
will
system
work.
will start. Okay. This is the RO system. Suppose morning 5 o'clock it has to start. Then I will put again stop time 5 o'clock evening. So automatically it will start and stop. Nobody has to come here to on off. It will do its job. Okay, this is program. Okay, every day we can assign. Daily 2 times also, 3 times also. Suppose I assign today Monday. Suppose today is a Tuesday. Suppose I put the here Tuesday and start morning 5 o'clock and stop middle 12 o'clock now. Then again I want to start 1 o'clock. I will put same day here again. 1 o'clock start. Again 5 o'clock stop.
This system can capability to
How to
remote.
edit?
Huh?
This system can have capable to remote this system. Like you want to access from other area.
There is a system
Yeah.
here, but it's still within program for that one.
That's better that one. So
There-
check what's happening. Oh, there is
You can check mobile also. Everything there embedded, but we have to work with IT with that one to get some additional things to be done in that one.
Yeah.
There we can make a free program. Same like a rinsing. Rinsing you see, waiting time 60 minutes, rinsing duration 10 minutes. Every hour 10 minutes you will do rinsing. Okay? But during dialysis it will not do. And heat disinfection. You press this one, you have a program already for Thursday, every Thursday evening time. 1930 it will automatically it will
start.
start. Okay, so you will not come and do manual. You will just come and monitor what's going on there. And any process going on, it will show you here. Like a dialysis now it's running. Okay, 10:30. When it was standby, it will show. So any other things, rinsing time, when it's run rinsing,
So there is
it will show. All these parameters can be read. And errors come, any errors come, running time or any in the past or daily. So all this, what is the error come, it will try to show over here. So we can view that one, we can see that one. And apart from that, we have here thermic conductivity, the graph, how the conductivity is going on, from how much it's taken up, down, all this conductivity, input, output, everything you can see.
How we can read this?
As we have seen, so CD1, color code, CD1. The CD1 is inlet conductivity. It was here, so it's high. Inlet conductivity. How much? It will be 60, up to 60. Okay, 60% and 14 microsiemens. Okay, so CD2. CD2 is, it started from here and sometime it went here also up to this much, 22. 95%, sometime, some cases. Okay, and CD3. CD3 is here. See, it is stable. So like then thermic consumption. This is how the graph checks. Thermic, how much water consumption, and how much drain, how much utilized. So this graph is trying to say. Okay. So how much here maximum and minimum. Heat dissipation. So during the heat dissipation time only, how the temperature rise, starting from here, and how it went up, and how it came down and cooled down. So this whole graph is there. Flow meter. The flow, water flow parameter, how the flow is going up, down, in that dialysis is running, more consuming, less consuming, all different there. Then system pressure, the pressures how it's going on. Okay, every pressure sensor, how it's up, go down, stable. So this is the pressure parameter.
And if the pressure sensor is damaged, it will show also flat reading.
Flat reading, even if you are seeing that like my pressure is now here, 10 bar. If the sensor is not reading, it should be 0 bar.
So the graph also is like
There's also
line.
straight line. Yeah. That also is on that one. Okay. And other some relay parameters. So relay are on off, which relay is off, on. It will try to show here. Relay parameters inside the relay. The machine inside. So input interface. Also try to show that some things, which things are right now starting up. So this is the electronics part. Okay, inside the board actually, which is try to run. So try to give the view of that one. Then operating data. So total how many hours is operated up to now, and how much dialysis run, how much feed water utilized, and how many hours pump run. So all these things can be seen from 1 minute. It's IO board related. Okay. So which components are on and off, relays are on and off. It is trying to show here.
So this relay input output can control in service.
Yeah, you can control.
That you want to test this solenoid valve. So that one is control of relay.
On and off only you can see. Other than that, we
Yeah.
cannot see anything this one.
So like for example, if this one is not opening, you can try and on.
We can see that one. No, that way we can't.
Cannot.
That is the diagnostic mode, I think.
We cannot do. No, here there is no diagnosis.
I don't no diagnostic.
Yeah.
That way we cannot see, but when it's running time, the parameters views we can see. Just like it's showing green, red, like everywhere you see.
It's
green,
running.
red, running on and off, we can see that. Okay. Okay. This IT what we can feed the IP configuration to access this one from our computer.
Yeah.
Anywhere from our computer, we can just access direct. Same like on off, everything we can see from our computer.
So, but now still not yet.
That is
configured.
there, but we are not using. We used to keep accessing my computer.
I think this same display will be appear in the
Yeah,
system.
same display will appear.
You can be
But
monitor
only in one network only. It's not able to link for other. Same domain only, we can anywhere. Same domain. If you are Aditya, you can
Yeah.
view from there, but it could be the one domain, one server. One server means you can access.
संफर भाई थोड़ा सा ये मेम्ब्रेन का ब्रीफ कर दो ना
Okay.
मेम्ब्रेन का
Membrane is actually what is trying to do is it will take the water, and the water there will be definitely enterotoxin and bacteria. Okay, maximum it's trying to trap that thing, enterotoxin and bacteria.
Intro, organic,
एंडोटॉक्सिन
Membrane.
introtoxin.
Endotoxin.
Endotoxin.
Is like a dead bacteria called endotoxin. But water normally there is in the water bacteria. Then we put some chemical or something, we will kill the bacteria. That is the time it will form the endotoxin. That is called endotoxin. The dead bacteria become endotoxin. Okay? The dead bacteria counting we are taking, and the live bacteria counting we are taking. These two are we are taking. So that membrane what is trying to do is, it is trying to, there are many very small point something micron
माइक्रो सीमेंस
filters, the fibers are there inside. So the water will go, when the pump is running, it's high pressure, it's trying to push the water through that membrane. Okay, so it's a small holes are there, you can't see that one, that much very small.
Pores.
Through that it will pass the water to trap that all the enterotoxin bacteria and trying to hold over there. Okay, so after that the water which is coming out will be a clean water. Okay, so this is what the membrane is trying to do it, and also it will try to remove some components like a chemical kind of
मैग्नीशियम पॉल
magnesium is already removed.
हाँ इसका कार्बन
Other chemicals. Apart from magnesium, calcium, there are other 24 chemicals are there. So in that chemicals also in trying to extract from the membrane. After that membrane, when you see the pH and other elements of the water will be very less. Okay, it's like a still water after this. Okay, so this is what the membrane is trying to do. So in a model system, when we see here, the same thing. Nothing to explain. The same thing, same function will be there. So we just come for the next step.
But the input of this water
No, that is not sun, I will tell you. So this is separate and that is separate. You see now, the RO, first RO is connected. This is the two first RO, okay? This is the second one. So this is the first and this is second. See, both are coming here now. Okay?
okay.
So one of them will connected here, the other one of them will connected here. So both will not at a time now. So suppose this RO is running, it will take inlet from here. So this RO is running, it will take inlet from here. So this is non-return valve, so it will not allow the water to come back. Okay, this is a non-return valve. So any RO is running, you are running RO number 1 or RO number 2, it will take the water from here. Okay, this is the output of the RO system. This is the one output of the RO system, this is the second RO output of RO system.
So this is the last stage before it will go to the patient.
This is the last area. So this is also they have a program now. This RO is running, automatically it will take the test. It's automatic. Today this RO running, tomorrow that RO running, it's a program. So it doesn't mean anything, this RO has to run, that, nothing like that. Any RO can be run, it's automatic program. So the water will come over here, then this water will go to the tank. Okay? This is only for heating purpose. During the heat disinfection only we will utilize this water. This water will be not utilized for patient side.
Okay.
Now this water will go to the tank and filling and making ready, the tank is producing. It is always ready for disinfection.
So but the water before it will go to the patient area,
Yeah.
should be passed here.
Yeah. Now you see that one, part of it will go that tank, right? It will make it ready and it will, this part is filling and it will filled and it will be whatever, made ready for a disinfection. So other part will go here, you see, here, the drum. This is the same line which is coming, one way this one will not go down, so it will go here, then it will come to the membrane. This is called ultra filter, special filter.
Ultrafilter.
This ultra filter, again, the first stage they already remove the bacteria and the enterotoxin. Here, more than that, here it's trying to remove everything now again, second stage. So after this output, it will go to the patient area. Okay, after this output. Okay, so this will come inside, then output you see, go there, here. Okay, this is the loop. Okay, this is going to the patient. Output of this one will come here. Okay. So this is going to the patient one and then return again. The loop is connected in one circle. one circle that way. In beginning, yeah. It is going to the patient, then return. Return. Okay.
This one is going. This is begin. This one is written up.
Yeah, there also we have two different loops actually here. It's a two system because our loop is divided into two. One side female, one side male. That's why they are connecting like this. Two different. One loop we are bringing and joining, and other loop and we are bringing and joining. Also both are joined together, but its functioning time it's only one. Motor is going to everywhere at a time only. Okay. So dividing only this area only we are doing divide because of this very big loop. Okay. So water inlet will go from here, from the ring begin. Will go there. Okay, one of them will work. Then the return will be there. At the same time, it will go to the patient area. Then return will come. So this is going to the patient area. Then return will come. So the whole the return again will go back to this one. Partially it will go to the drain. Then partially will be saved there. There is return. This is return. So from here,
the inside.
No. This is input coming from the RO.
We have this is called the timekeeper battery. This is the battery in this one. There's no any other type battery. This is the battery. Timekeeping battery. Okay. So and the other breakers are there, and the contactors are there to turn off the pump and switching the pump. Okay. So mainly this all things are programmed in this one. How to control the RO1 and 2? They have made a program in this one. Okay.
So there is a control here also, RO1, RO2.
RO1 and 2, there is no, it's there, but it will not show you like that. Here you see now, it's showing dialysis. Okay, so this, like, suppose I switch it off from here now, all the dialysis system will be shut down. Pump 1, I mean the RO1, RO2, whoever they're running right now, they will switch off. So this is called like they made a system, main control from here. The all control will go from here to RO1 and RO2. Suppose RO1 is today running, so when you on off from here, it will off. When you on from here, it will on the same. Okay, and this other thing is here nothing for RO to control the RO, only for on and off only. They will not show anything over there. Remaining is we are having here for heat distribution system. This control system completely used for the heat distribution system only. Okay? Yeah, during the heat distribution system, you can just go for heat distribution. Suppose if I go and select now, it will start the heat distribution. But right now it will not start. If I start, it will try to give some error message because your RO is running. I can't start.
So
Okay?
it should be standby mode on the RO or off.
Off. Yeah.
I should be off the RO.
RO should be off. Standby, not off. Standby.
Standby.
Because it need a water from there here. Whenever the water is poured down, it will take the water from there. So here also we have program. You can program automatic starting dialysis or automatic off the dialysis and automatic heat distribution system. Which time you want to do all these things we have already programmed. We have programmed in this one. So timer we can make a timer dialysis and timer distribution system. So I will show you that one. So every Friday we are doing these two loops are there. One loop will start 4 o'clock. After finish, the second loop will start 6 o'clock. Automatic hot cleaning.
So during this time, we cannot use the dialysis.
That's why we are doing Friday.
So,
We are working on Friday for that.
so they know already that one that you have
Friday we are scheduled for
schedule every
dialysis
Friday.
only.
But once the heat distribution is started, we can be terminate this one.
Yeah, we can terminate, but like 10 to 15 minutes, it will take time to completely cool down. Means it will go that it will consider like it started the heat distribution.
Did you experience this one in the last few?
Yeah, we experienced.
That the patient is come immediately and they have urgent
If a patient will
therapy.
come like that,
Then you have to stop
will not
that.
let them to take the patient like that. It will not happen like that.
Because immediately the RO will be not start. So it will
Can't
take
take
maybe
the RO.
one.
If they want to, they can't do the dialysis. We are not allowing to do the dialysis for them. That case, they have to take the CRRT of the portable RO. We have to disinfect this RO system because if this contamination is something wrong, next whole day we cannot run the dialysis. So we will not give that chance. Friday we fix our schedule for disinfection.
But
Friday if you have a patient, use the portable RO. If not CRRT machine like that.
So the RO will deploy automatic analyzer every Friday.
Yeah.
So
Yeah,
we
every
are the one start.
We are the one.
We are the
We are the
one.
one coming here Friday.
And we will
Sir, and we will
install
monitor till this
protocol.
mission finish.
In the morning.
We will finish this mission, then we will go home. So, this one anyhow, later on when you are having a system here, you will learn deep in this one how your operation, what's going on. Now because you will get confused, what is that? Because
Yeah.
you don't have a system over there. You must, that's only for idea only I will
Okay, finish.
Okay. So this is what exactly what's going on in the RO room, RO system, and what is the function of that one. And I also show you that one water guard, that is its function, what it's trying to do. So
This is the short
we are
training
seeing
for
that
the
one. Suppose we put any water detector here, we will try to alarm as well as to try to stop the. That's a